this unit. Okay, this is where the algebra is going to step up a little bit. So what we're going to now be able to do, we're going to solve systems of equations without any sort of graphing. Not by hand, not using your calculator. If I get the sense that people are just doing it on their calculator and not doing it by hand, we will write a test with no calculators. If I get a sense that you're actually practicing and doing this, then I'll trust that you're actually able to do it by hand on the test. And you'll have your calculator for your test. Does that seem fair? Okay. Because it is important that you're able to do it both ways. So, when we are trying to find the answer to a system of equations, what are we looking for? On a graph, what are we looking for? Last class, what were we trying to find on a graph of a system of equations? Where they intersect. We're trying to find a shared point. Now we're going to be able to find that shared point by hand without actually drawing it out. So, here's the easy steps to do it. You're going to choose the easier looking equation. So when you look at the two equations, you're going to pick the one that just looks easy. Whatever that means to you. Who is it? Ridiculous. Okay. You're going to pick the easier equation. The easier equation is probably the one that doesn't have like a bunch of square roots or doesn't have like a whole whack of variables, stuff like that.
You're funny.
Thanks. Then what you're going to do is you're going to try to isolate one of the variables, whichever one's easier. So if you have an equation like this, it's 2x is equal to 4y plus 11, it's pretty easy to just isolate x right now. You just divide everything by 2, right? So you're going to isolate whichever one you want, whichever one's easier to isolate. Then you're going to take that and you're going to do what we refer to as substituting. We're going to substitute, we're used to substituting individual numbers, where it's like substitute 2 in for x. Now we're going to substitute in entire equations. Yeah, okay. That's where the algebra is going to get a little more complex. Then we're going to distribute, combine like terms, and essentially just solve equations. You're going to isolate again. You're going to substitute the number found in number 4. So like if x was equal to 7, we would put that number in. That's the easy substitution. We know that. And then we're just going to solve it for the other variable. It's tough to kind of read through all these steps and not do it. So let's just do some. Okay. Here's two equations. Together they create a system of equations. Let's try to solve them. So step 1 was pick the easier looking equation. This one looks pretty darn easy to me. I don't know. They both look pretty easy. But I'm going to pick this one. Now it says isolate a variable. I'm going to isolate x, just because. You could isolate y, that'd be fine. I'm going to isolate x. To isolate x, I have to minus 4y from both sides. So now I have x is equal to 17 minus 4y. Easy. But now, because we have a system of equations, we can use this to our advantage. Because we have said that the system of equations, they are connected. And since x is equal to all of this, we can just substitute it in right here. And then we would have an equation with only one variable, just y. Does that make sense? We're going to go from, right now, both equations have two variables. We have two equations with two variables. If we change x into 17 minus 4y, because that's what we said x is equal to, so we take that chunk, substitute it in here, now we're going to have 2 times 17 minus 4y minus y. We won't have any x variables left. Then we can solve for y. Let's give it a try. X is equal to 17 minus 4y. We are going to put that right there. And we're going to use brackets to do it. So it becomes 2 in brackets, 17 minus 4y. And the rest of the equation is still the same. So minus y equals 7. Everybody cool with that step? Any questions about how it happened? Time. Did not follow. Okay. In both equations, x and y are the same thing. We just don't know what they are, right? We just know it's x and we know it's y. We could say it's the price of a child's ticket and the price of an adult ticket. Using the first equation, we found out that the price of a child's ticket is equal to 17 minus 4 times the price of an adult ticket. So I can just take that, since I know that's the price of a child's ticket, and put it in here, where it says price of a child's ticket. And now I have everything in terms of just an adult ticket. So now I can figure out what an adult ticket's worth, or I can figure out what y is equal to.
I think people aren't going to figure out that whenever you're supposed to fill in something for x, usually when you use one letter, so or one number, it's easy.
Yeah, we're used to just doing a letter, like a x equals 2. This is x equal to a whole whack of crap, which is why it makes the algebra a little bit trickier. The next big thing we're going to have to figure out is we're going to have to remember the very first couple units. How do you get that 2 inside the brackets? You have to multiply them. So that 2 multiplies to both things. So your new answer would be 34 minus 8y. And because I distributed it in, the brackets are now gone. Minus y equal to 7 still.
Can't you put the y's together?
Exactly. Now you combine your like terms. The y's come together. 34 minus 9y is equal to 7. Now you just have to isolate y. The 9 came from 8 minus 1. So I took 8 y's and I subtracted another y. Now I have minus 9 y's. Yeah? Okay. Now I have to isolate y. To isolate y, I'm going to have to, there's 2 ways to do this. You could just move the number over there and make it positive and move the 7 over. And then you're not divided by negatives. But if you're fine with dividing by negatives, we'll just move the 34 over. That's what we're going to do because it's easier. Whenever possible, I like to just leave the y's alone. Just makes it easier to talk about. So, how do we do this? Does everybody have all that written down on the left side? Okay, I'm just going to move my work straight.
Where's your x?
So there is no x in the new equation. So in the new equation that I've made over here, right, there is no x anymore. If we turn that x into a y system. Okay, I'm going to move this up here. I'm going to subtract 34 from both sides. So I have negative 9y is equal to negative 27. The negative 27 came from 7 minus 34. Finally, how do I get rid of this negative 9? Can I add negative 9? I don't want to get to 0. I want 9 by y by itself. Divided by. So I'm going to divide both sides by negative 9. And you should get that y is equal to 3. Y is equal to 3 is great. That's half of our answer. That only gives us one part of the point we're looking for. How are we going to figure out the other point? Mile. Now you can substitute 3 into one of the original equations. And that will give you your x value. I'm going to erase this right-hand side. Is everyone okay with that? Okay. by substituting 3 into this equation, I now have x plus 4 times 3 is equal to 17. That's x is plus 12 is equal to 17. So x is equal to 5. Where did I get what? That was quick, so ask. Where did I get this? The negative divided by a negative turned into a positive 3. Right here. So you're talking with this step? It's x plus, so I took it from this, I used this equation. You can use either or. If you decided to substitute 3 into that one, you would also get x is equal to 5. Right in the board screen.
Like already preparing your x, like -7 for y.
Yep. You could do that as well and figure out your x. Yeah. So we had x is equal to, it was like 17 minus 4y. You could also substitute the x in there and find it. Also give you the right answer.
I wasn't paying attention to that 27.
The negative 27 came from the stuff that I erased. So the negative 27 came from solving this part of the equation. So I had solved all this on the left side and then moved it over, and it gave me negative 27.
No. Why would you always solve when you can just go x, subtract x, go 5 outside, 3, 4, and doing that? And did you find put that in a calculator or find that for your y equals?
I think I know what you're talking about. That's the next lesson. So what you're trying to describe is the next lesson. This is by substitution, meaning we substituted in the entire formula. What you're talking about also works. You're subtracting, right? Is that what you want to do? Subtract the two equations?
I'll look at the class.
Yeah, sounds good. Okay. Question 2. Step me through it. What's the first thing I gotta do? Look for the easier equation. Which equation looks easier to you, Joe? Go to the 0? Yeah, I'm on board with that. Okay, so what do you want to isolate? You want to isolate y? Doesn't matter. You choose. Choose whatever you want. Let's isolate y. So he chose this equation. That's step 1. Step 2 is choose a variable to isolate. He's going to isolate y. To isolate y, I have to subtract 4x from both sides. So minus 4x from both sides, and you get 3y is equal to negative 4x. I'm not done isolating it yet. What do I have to do? Aaron, divide both sides by 3. Now I have y is equal to negative 4 over 3 times x. Beautiful. Step 1, choose an equation. Step 2, isolate a variable in that equation. Step 3 is I have to now substitute this in somewhere. You have to substitute it into the other equation that we haven't worked with yet. So let's do that. 8x minus 9 times, and you substituted all this stuff for y, so times negative 4x divided by 3 is all equal to 5. You can see how this algebra can get confusing in a hurry. Alright. Let's multiply that 9 in. When you multiply a number into a fraction, you only have to multiply the top number. Only the numerator. So it becomes 8x minus 9 times negative 4 is negative 36. Negative 36x divided by 3 still equal to 5. Come on. I did subtract. So 9 times 4 over 3? Yeah, that's what I've done. And I've left it in a fraction form still. So that's 9 times 4 over 3 would be 36 over 3. Right? Does that make sense? Gold. Absolutely. What's 36 divided by 3? 12. So let's make it easy on ourselves. 8x minus negative 12x is equal to 5. Why not? That looks so much better. Good? Yep, and that's the next step. If you're subtracting a negative, it's just adding. Right? Subtracting a negative. So make it easier on yourself again. 8x plus 12x is equal to 5. Now we have to what, Aaron?
Just a question. Do you put brackets in the negative out or?
Yeah, so it would be bracket here, right? Which if you're subtracting a negative part.
What of the negative 36x over 3? You put it over.
You could if you wanted to, yeah. Yeah. Just helps you remember that there's a negative sign there. That's fine if you want to put brackets. You don't have to. That's preference up to you guys. Combine like terms, right? Now you have 20x is equal to 5. The 20x comes from 8 plus 12. Now we divide both sides by what, Dawson? 20, yeah. And you'll get x is equal to 1 over 4. 5 divided by 20 is the same as 1 over 4, or 1/4. That's only half of our answer. How do we get the other half of our answer? Nope, not for this question. We got the other half of the answer up there.
So we need y and x.
We need a y value. We don't have a y value yet.
Y equals 4x over 3.
Right, but that's not a number. That's a number times a variable. We want just a straight number. I see what you're saying. So he was saying, we already have y. But you couldn't plot that, could you? You need numbers that you can plot. So what do we have to do, Brady? Yep. We subtracted a negative. So it's like adding. X is equal to 1/4. Aaron, what do we have to do? You got it. We have to plug it in. So I'm going to substitute now this into this. That means I'm going to have 4 times 1 over 4 plus 3y. Whoa! What am I? Oh yeah, that's right. I'm confusing myself now. 4 times 1 over 4 plus 3y is equal to 0. So we're solving for y now. Oh, I see that. 4 times 1/4 is just 1 plus 3y equal to 0. We move our 1 over, so now it's 3y is equal to negative 1. Because we have to subtract 1 from both sides. Then we divide both sides by 3, so y is equal to negative 1/3. Does that make sense? It's just a lot of mathing. It's nothing crazy, it's just a lot of math. Here, a more complex question of the same thing. Okay, we'll do this one. The next ones are just review. Remember how we said we chose an equation at the very beginning? Which equation do you want? You want the one that looks easier. Which one of these looks easier? The first one? If you were to ask me, I'd say the first one. I think the first one looks easier. Yeah. And there's a lot more negatives on the other one, and that's, I don't like that. And yeah, B's already by itself, right? Brayden said the B's already by itself. Yeah, that's nice. Then we can isolate B, and it's pretty quick and easy. So yeah, let's do that. Aaron.
2 times 5 and then 2 and 3.
Yep. The very first thing you want to do is multiply that 5 in. So now you have 10a minus 15 plus b is equal to 5. I'm going to add 15 to both sides. Now I have 10a plus b is equal to 20. We're isolating b, right, because it's already by itself. So subtract 10a from both sides. And you get b is equal to 20 minus 10a. Too far out? Easy? Good. Step 1, pick one of the lines to use. Step 2, isolate a variable. Step 3, substitute what you found into the other. So let's do that. We're going to substitute this in with D up there. 6a minus 2 times, and then you're going to have 20 minus 10a minus 4. That is a lot of math. And the brackets inside of brackets. And those brackets really aren't doing anything for me right now. I always put brackets on things when I substitute them in, but those ones are pretty relevant. So we're just going to get rid of them because they're not holding us away from anything, are they? Aaron. The negative 2 you could multiply in, but what you can also do is recognize that there's nothing in between these brackets right here. So you can just combine your like terms in the middle first, in between those big set of brackets. Josh? It wouldn't change anything if you did it properly. You get the right answer both ways.
50 times minus 4.
Nope, you're not multiplying minus 4 because it's minus 4, not multiplied by minus 4. Well, that's a good question. If you had a negative 4 in front of it, you would multiply it, but it's after it, so it's just subtracting. So what we want to do is it goes 6a minus 2 times 16 minus 10a equals 20. And now you can multiply your negative to it. And if you multiply the 2 in, as long as you multiply it to each thing, you're good. Doesn't matter. Yeah, you'll get the same answer no matter what.
Why do you like subtract this 20?
40 minus 8. Yeah, pardon? Because the 4 isn't attached to a variable. The 10 is 10a, right? Right, they're non-like terms, so you wouldn't combine them. Alright, multiply this 2 in. The negative 2 in. So it's 6a minus 32 plus 20a is equal to 20. Because I multiplied negative 2 in. Make sense? And then like terms again. So now you got 26a minus 32 equals 20. How do you bring the 32 over? What do you have to do? Add it. You do the opposite of whatever showing. So you add 32 to both sides. 26a is equal to 52.
But that would seem like it's gonna work. Wait,
What do you mean? Like if you had done the 2 in first? Yeah, that's fine then. If you get that, that's good. Just divide by 26. A is equal to 2.
Whoa.
I'm just going to draw a red line in here just to separate our work here. A equals 2 is only half our answer. We need to figure out what B is equal to. So you put that into anything you want. I'm going to put it into this. That will usually be easier. You've already isolated this out, right? See this right here? I'm going to highlight it in green. If you substitute into your original isolation and you isolated it properly, you'll get the right answers. Yeah, so B is equal to 20 minus 10 times 2. B is equal to 20 minus 20. B is equal to 0. Good job, Johnny. If you substituted A equals 2 into this, you get B is equal to 0. If you substitute into this up here, you also get B is equal to 0. Get 0? Which one did you substitute into? The original one? Okay. I'm going to talk it through real quick, okay? So substituted 2 there. So that's 4 minus 1, or minus 3. So it's 1. 5 times 1 is 5. Subtract 5 for both sides. 5 minus 5 is 0. A is equal to, B is equal to 0. Johnny? Yes, sir. Alright. Quick review from literally this morning. How do you know the number of solutions just by looking at it in slope-intercept form, Matthew? Great, but just looking at the form, how can you tell how many solutions there are, Liam?
If those the wires that we slopes are like all are different than it is.
If they're all different, so if you have different slopes and different y-intercepts, you have one solution. What's another way that it could go, Ella? Exactly. So if you have the same slope but different y-intercepts, you have parallel lines, which means you got no solutions. So what's the final one, Reagan? Yep. So if the slopes are the same and the y-intercepts are the same, you have infinite solutions because their lines are on top of each other. If you want to do some review from this morning, feel free to do that question on your calculator. See if you can get it right. We just did it this morning, so you have lots of time to practice it. Okay, I'm going to give us a break rather than do the next lesson, as long as we work for the next 25 minutes on our practice booklets. Great.